When we have a vector field that is conservative, the work done moving an object from point A to point B turns out to be the same quantity no matter what path we choose. We call this being path independent. That means if we have a conservative vector field and our object initially starts at point A, the work done moving an object along path C1 is the same as the work done moving an object along path C2. To consider how this might be true, let's remember that a conservative vector field will have a potential function f at x, y such that the gradient of that potential function is equal to the vector field. And by the fundamental theorem of line integrals, we saw that this work could be calculated by plugging the terminal point and the initial point into that potential function. And that terminal point and initial point are the same no matter what path we choose. The path was not considered in the calculation. And so if we have a conservative vector field where the fundamental theorem of line integrals can be applied, then the work done is considered to be path independent. The work done moving along path C1 is the same as the work done moving along path C2. Let's also define what it means to be a closed path and a simple curve. A curve that's not simple is going to pass over itself somewhere. I'm going to have some sort of a loop along the path. But if there are no loops in the path, then we say this is a simple curve. There are no places where this curve crosses over itself, so it too is simple. Now we call a curve closed if we start and stop at the same position. So if our start value is time is equal to A and our finish value is time is equal to B, if we are at the same position at those two times, then we are a closed path, meaning that we start and stop at the same point. So this curve here is not closed. We do not enclose a region. This curve here also not closed. But this curve starts and stops at the same point, so we would say this one is a simple and closed curve. Now back over here in this corner, we'll notice that this one is not simple because it crosses over itself at some point. So this curve down here is closed but not simple. When referring to a simply connected domain region, a domain region is simply connected when there are no holes or channels or anything in the interior of that domain region. And several of our theorems involving line integrals require simply connected domain regions.